uploaded the data set and the file that we are going to practice today.
Okay. So, as you know, Neha, please once again message them about the drive folder link. And Shubhangi has also uploaded this data on which you are going to do the experimentation today. So please have a look there. Okay. So Shubhangi, you will please start.
Thank you, ma'am.
Thank you.
So very good evening, everyone. So on today's lab session, I have prepared a lecture, a lab on classification and supervised learning. So here you can see that in day2 folder, inside the lab folder, there is a data set named as train.csv and a Python notebook file. So I request you all to please download this train.csv file and upload that data set into one of your drive inside your drive. Do not write in that Python notebook. Please upload this data set inside your drive. Like I have created a new folder, and inside that I'm writing AIML. So here I already have my data set. So I will start with my Python notebook. So you can right click, and here you can see more option, and here you have a Google Collaboratory option. So please click this so that you can create a new Python notebook, and you will be getting into the Google Collab. Here we will be writing our code for today's lab. Let me rename this as classification using supervised learning. So once we start with this, the main thing that we require is mounting the drive. The data set that we have, we need to read that data set. So for that, mounting is required. So please see these instructions. Here in the left panel, you have mount drive option, this mount drive option. Please click on this. Once you click, this type of permission would be required. So connect to Google Drive. So here I have been mounted. Here you can get an option to which drive you want to mount. So please provide click on that particular your mail address. So here I have got this drive. Inside this I have a data set. So here I have it. Wherever you have kept your data set, please go to that particular path and then read that data set. So I have this. I already have it. So I'm reading it. Before that, you would be getting a content drive one from Google Collaboratory. If someone is not getting this mount drive options, then you can write this command also. So you can write this particular command from Google.collab import drive drive.mount / content / drive. This is another option to mount your drive. Run this cell. This type of message would again pop up. So I already have mounted this, so I don't require this thing. But if someone want to write this, then you can get. So now we will first of all import important libraries. So import pandas. First of all, pandas would be required to read the message, to read your data. Pandas as PD. PD is the alias that we are giving. Import numpy as np and import matplotlib.pyplot as CLT. So we can run this cell. Now we will have to read our data. So for this, we require I have already shared the data set. Someone has messaged me, so please go to the lab folder in Day2, inside Day2, where to type the instructions. Instructions are to be typed in this collaboratory. I have told you to go to your particular path where you are going to write inside your drive, and then right click it, and then
Shubhangi?
Yes, ma'am.
If you don't mind, can you please also see the chat box?
Ma'am, yes, ma'am.
Some person is asking Sneha where to type the instructions, madam. Can you please once again tell? Thank you.
Yes, ma'am. So here in this folder, wherever you want to create your notebook, right click it, go to more options, and here you will find Google Collaboratory. If you do not have Google Collaboratory, then please click this one, plus connect more apps. There you can find that you have Google Collaboratory, and then install it. So I have answered these questions. Now we are going to read the dataset. So for this, we are using the alias name of pandas at pd dot read CSV. We are having the format in CSV file, CSV, and then we will provide the path. So I was telling where my data set is. I am having here inside the FTP Asia Connect, ML and AI. So here, wherever you have your data set, please copy that path, right click it, and then copy path option, and then paste over here. So you can read this and then write DFs. So till here, I can hope that you are able to read the data set. Here, using DF, what we are seeing that we can see the data frame. Our data is stored in form of data frame, where this table, in table format, everything can be displayed. So here you can see below 2000 rows are present inside the data set, and 21 columns are there. So please repeat. So, okay, I will repeat it again. First of all, we have mounted the drive. Go to this left side, here this folder path, then click either click this icon, so that you have mount drive option, and then a pop-up would be coming to mount the drive to a particular your email drive. So click on that pop-up and connect it. Then you can inside drive you can see various folders, your drive folders. There you can go to the particular path where your data set is present. So there you go to that folder and then right click on it, right click it, copy path, and then paste that path over here. Okay, so this is how you can read the data set. Then we have imported these important libraries. This is what till now we have seen. Okay, it is not clear. Let me increase my font size. I hope now it is clear. I have increased the font size. Okay, so here you can see there are various columns present over here, and where you have battery power, blue, clock speed, dual SIM, FC, 4G. These are all the features on which training is to be given, and then we have a price range. So we have in total 2000 rows and 21 columns. So let us now, first of all, begin with the description of this data set, what this data set is all about. This is a mobile data set. It is having approximately about 20 features that are relevant. Here you can see that what is the battery power, then you have the clock speed of the microprocessor, then you have front camera megapixel, then mobile weight is also present, then you have height and width pixels, then screen height is also there. Does this phone has 3G, it has touch screen or not? So all these things are present over here. So according to that, price ranges are also given. So range is in form of what? Very low, medium cost, high cost, or very high cost. So numbers are given to this, like 0 is for low cost, 1 is for medium cost, 2 is for high cost, and 3 is for very high cost. Okay, so these things. Okay, so I was looking into the chat. So no questions till now. I hope that you are able to read the data. Can you please reply? Okay, thank you. Thank you, everyone. Okay, so till now, here, like we can see the data set. Now, next command is our df.head. This df.head is used to see the top 5 rows of data. So you can see the top 5 rows over here using df.head. So next, we will first of all visualize things how different data frame instructions are given. df.describe. So df.describe tells you different types of parameters like count, mean, standard deviation, what is the minimum range of this particular column value, then the percentiles, different types of percentiles, its default is 25, 50%, 75%, then maximum range also. So these types of various values are provided using df.describe. This is only sometimes required when you are trying to see various values of the data set. So at that time, this would be required. So for that, I am telling you these things. Okay. Can you please show the cell once again? So okay, I have scrolled this up. df.head and df.describe was there. Okay, so next is our next command would be df.info. Info. It tells you the basic information about this data set, such as whether what is the data type of this particular column, then what is the data type of this particular column, then what is the data type of this particular row, then what is the data type of this particular So you can run this. My cell is still running. due to some internet connection issue. Okay, so you can see like here. So these are all non-null values. Sometimes null is present, so you have to replace those values using some other value like median, standard deviation, anything like that. So in few problems, you have to first of all see that is null is present or not in this particular data or not. So this thing is required. Then you can also see the value counts, how many counts are present for a particular class. Like we have a data frame TF, and we will see it for the last column, that is the price range dot values value counts and now we go. So we can see that 500 values are there for one, means that represents, what does that represent? One value represent medium cost, 0 represent the very low cost mobile. So how many rows are there? So it is quite a balanced type of data. Then let us see that how many is null values are there. df dot is null dot sum. There is no null, so everything is going showing us 0. Don't have. We are doing classification. Now we are not doing regression problem. Okay, regression is in our next upcoming labs. So this question was on chat box. So I have answered this. Please show the starting cell. Just a minute. This is the starting cell. Okay. This is the starting cell. Then we have df.head, df.describe, info, and then value counts. Okay. So I'm giving you 2 minutes so that if someone is behind us, then they can write it. I'm giving you few minutes to do it. Okay. Then we will see how these things can be visualized in form of graphs. So in chat, someone has written price range is the label here. Yes, you are correct. Price range is our label. What is classification? Can you tell us briefly? Classification is where we are going to train the model on some few rows. That would be the train test, and its label would be the price range. So here discrete values are present in terms of 0, 1, 2, and 3. So it is the discrete value, not the continuous value. So this we would be predicting that after training, what upon the test data set, what it is going to return the particular output of the label. That is what is classification. Okay, so let us now start with our exploratory data analysis. So first of all, we would be listening to now what we are going to write. We are going to see the histogram of some of the columns. So write DF. We will see on battery power. Okay, first of all, here battery power. So we will see its histogram. So like this, you can visualize that how many values particular row and column is having. So here, another feature also you can take like clock speed. You can see mobile weight. Let us see PF mobile weight dot hist. So here also you can see that there is not very much fluctuation in the values. They are approximately very close to each other. So for that thing, this histogram is helpful to see if there is a variation in values, like one is 0, then another one is 1000, and in between there are different values present. So for that type of visualization, this histogram are helpful. Another technique is the visualizing the scatter plot. So for the let us write code for seeing that the scatter plot. First of all, let's give the colors. We are giving red, orange, then blue, and green. And our price range is in 0, 1, 2, and 3. So we will iterate it up to 4 because our colors are our price range is in 4 values. So for I in range 4, x equals to df df price range is equal to PLT dot scatter to print the scatter plots. Then we have X. I'll be taking mobile weight as one of the dimension. Mobile weight and X and RAM as another one, and we will see that on based on these two features where the price range is present. So according to that, we will be printing the scatter plot. So C is equal to colors of I, label range of I. So our X label would be the mobile weight Y label is RAM. Someone is having problem to access the data set. Okay, I will tell you one thing. So like this, here you can see this type of scatter plot, as we have many uh, uh, data points. So here too much clumsy type of thing you can see, but actually what it want to depict is that based on these two RAM and mobile weight, where this particular on this, based on this particular thing, where this point is present, data point is present. So our value of very low, then medium, then high, and very high values where this thing is present. So based on this type of analysis, you can see that it can be very helpful during your dataset visualization. So this is just a thing to tell you that how you can visualize your dataset, uh, what type of data points are present. So this would be helpful to you. So now let me write. Please show the code once again. We are not done. Okay. So you can write this code. First of all, let me tell someone that was asking that he was having problem on reading the data set. I'm once again telling, please go to this particular icon, mount the drive, then a pop-up would be coming. Please click on the particular drive, click on yes, and then drive, go to this drive, my drive, and then the path where your data set is present. Right click on that, copy that path, and then you can paste this particular path over here. So this is how you can read the data. I hope this time you have original data set is present. Original data set is present inside the lab folder of day 2. You have to download that file, and then you have to upload that file into a particular location on your particular where you want to access it. Okay, do not try to copy from do not try to read it from directly from the day 2 folder. Okay, so let me go over here and you can write this thing. So I'm giving you some time to write this thing. Yes, this file would be shared. I have already shared this file, and I will again share it if this particular file also. Okay. Someone is asking PLT.legend is for this thing where you can see 0, 1, 2, 3, which colors are given over here. So this is what is displayed using PLT.legend. Okay. Okay. So I hope till now everyone has written this. So let us continue. So now what we are going to do is that sometimes when we have a label, it is not given values like 0, 1, 2, 3. There are values given in form of, yes?
Ma'am, I am unable to load my data. I have connected it to Drive twice, one time, but I can't find any such options as there are on your screen.
So you can type this command also if you are not able to connect through this folder, this icon. You can use this command.
Okay, ma'am.
So
Okay.
this
This would
path
also.
has to be like
She will give, maybe she has given a wrong
different
path.
path. Yeah,
You are
that
giving
might
the
be.
different path.
She might have used
Yes.
a different path.
So can I continue, ma'am?
No, I mean, first let her,
Let her. Okay.
you please follow on the path. We just see where your file is. You have to give path of your file, basically.
Yes, she might have kept it in another drive and she's connecting to another drive. That is the
Yeah,
problem.
probably. I
Okay.
don't know.
You,
That could be
so
the reason.
I hope that you are logged into particular whichever Gmail you are over. In that particular drive, you have to mount this thing. Okay. Your collaboratory file is present in which drive? That in that drive only you have to mount this thing.
I think let's continue. She will because there are a large number of students who are not having problem. So Mahadevi Singh, you please approach her separately. Okay. You can continue, Shubhangi.
Shubhangi, you can continue, please. Shubhangi, are you there?
Actually, there is some unstable. Our network is unstable today, so she got disconnected. Perhaps.
Yeah, she will join. Just a couple of minutes. She will join again.
Wait for a while. She will join.
Sorry, I got disconnected. So we were writing the encoding thing. So first of all, let me tell you that here, as we can see our label, our target label is what is the price range. So here we have a price range in 0, 1, 2, 3, 4. Sometimes there in string format something is written like low, very low range, range, very high range. So these types of things needed to be encoded. So for this thing, what we do is use label encoder. So first of all, see tf dot head So we have 1 2 2 1. In this particular data set, we don't require it, although, but then also some of the data set deals with this. So I am telling you for those things. So you can use it afterwards, this particular concept. So for this, you have from sklearn dot pre-processing import label encoder and then we have label encoder. So it is present inside here sklearn.preprocessing.label encoder. So you can visit this particular website and read this. So from here we are importing the label encoder. So let us run this cell. This is to change it into an encoded form, our target label. Here, I'm again telling you that here we do not require it, but there are few data sets which contains the target label in form of strings or words, alphabet. So there you want to write it in form of 0, 1, 2, 3 form. So there you must do this thing. So for that, we have price range, then le.fit transform df and inside that price range. So let us see, although it is not going to make any change. Here we have again that same thing, price range as this thing. So whenever you have something written over here in form of string, so that would get itself changed into an encoded form. So for that, this is required. You can write this particular thing. Till that time, I'm looking into the chat box. Encoding, I'm telling you that here, low price represent 0, then medium represent 1, high represent 2, and very high represent 3. If this particular thing is not given in form of a numerical form, then we need to convert it to the
एशिया
numerical
कनेक्ट
form.
में सी कैपिटल कर दिया है और मैंने एशिया कनेक्ट का सी कैपिटल कर दिया है.
Okay, so you would have to convert it to the numerical format, and for that label encoding is required. Okay. So can I move ahead? Have you written? Yes, we are giving not in a range form, but we are encoding it, giving it in a numerical form. So it would be having 0, 1, 2, 3 values. So I hope till here, if you are able to do it till here, please respond it by writing it on the chat box so that we can move ahead. Or should I wait for a minute or a while? Okay, I will wait for a while so that few people are doing, they can do this. Which cell you want to see? Ma'am, it says cannot import. You would have done some spelling mistake. Ma'am, can you explain the code? That dot graph. Okay, I will explain. Okay, histogram first of all tells you the values, particular values. It is helpful in visualizing that what is the difference between various types of values. Does this graph has inconsistency, like one of the value is very low, another one is very high. For these types of analysis thing, histogram is very much useful. Transform is used for label encoding. It directly transforms your data to the numerical form. For that, bit transform was used. Okay, and it uses that. I have shown you the sklearn pre-processing label encoder thing here. This thing from here, it uses the fit transform. Okay. Another question was about import label encoder. So someone was asking about this thing code. Okay, so we have colors in four different colors. Then we have price range, because we have price range in four labels. So from here we will be retreating to four price ranges where we have the data frame of price range. We are reading the last column, and that particular column we have to print that particular data point based on the mobile weight and RAM. So based on that, where it falls, that is shown in the form of a scatter plot. This is actually used to see the clustering, that whether these clusters, in some of the cases, you can see that the clustering is very much compact type of, like greens are in one group, then another one is the blue. Here data points are very high, so that's why it is not very much clear. However, this thing is a type of clear thing only because based on the number of data points. So sometimes that more clear picture could be seen if these data points are lesser or they are clustered in a group, but in a better way. So this is basically just a visualization technique to see how these data points are correlated to each other. Okay, I hope till here things are done. Encoder code. So this is the encoder code. So can we move ahead if you are done with till now? If everyone is with me, then we can move ahead. Okay then. Now once we have done the encoding thing, then we need to do set what are x uh, stored in our x. So upon Okay, so we have to provide the training data and the test data, and inside that, upon which we are going to train, that would be having some label. So for predicting the label, we would be storing it in Y, that is the price, and the rest would be coming into our X features. So df dot drop columns. I will explain you why we are doing this. Column equals to price range and let us see X dot head. What this is going to do is we are having inside our DF everything, whatever was present in the data set, everything was there. We only require from this battery power until this Wi-Fi. We require only these many features, and the rest one, this price range is going to be our label vector. So this would be stored in another variable. So till here, so for this, we have to drop this particular column. For that, we are using df.drop command. So once we have df.drop, we have run. So we can see that our last column is what Wi-Fi, and we have dropped the price range column. Okay. I have repeated that thing why we are dropping this. During that, my voice got break. I have told you that we require to give a price range as the label. So this we would be storing it in a different variable in Y df dot df price range. Okay, and then see this as using df dot head. Sorry, y dot head. So yes, here you can see that X is now not containing this price range, but in Y variable we have the price range thing. Okay, so till here you can write it. I will also copy this thing. Okay, then all good till now. So we have given it the X and Y labels, and now we would be pre-processing. How we are going to pre-process data is in form of variety of ranges. So we have to bring it in a particular range. For that, pre-processing is required. So for that, we would be using the library of sklearn library, and we would be using min-max scaler. So we have from sklearn dot pre-processing import min max scaler. Min max scaler, and then we have extrained scaler. In this, we would be storing the updated values. Scaler dot fit transform and provide the particular value that we want to transform and run this thing. So this min-max scaler is given in here. You can see sklearn.preprocessing.min-max scaler. You can type this and see this thing. This sklearn provides various types of pre-processing things. Standard scaler is also there. So please, we are using here min-max scaler. So we are going to now see how values are changed. X trained scalar, sorry, X trained in the values. What exactly drop do? Drop is used to drop a column. Okay, we have dropped the price range column. For that, drop function was used. df.drop was used to drop this particular column. Okay, fine. So yes, we can see that we have uh, transformed the data to a particular range. Okay. I have told that a min-max scalar used to transform the data into a particular range. Like this is coming in between 0 to 1 values. For that, this is required to transform the data. Okay, let us now check. Let us now check the shape. Scalar dot shape. It would be showing you the number of rows and columns. So let's run this. So it has 2000 rows and 20 columns presented that. We have dropped the initial last price range one. Otherwise, we were having 21 columns. So here we have y dot shape also. Let's see y dot shape. Okay, so 2001 column are present over here. So this is only for again just rechecking that whether we are going into the right direction or not. Okay, so let's go with the Y shape. We are done. Now what we have in our data set, let us once see. I hope you can see the data set. Here you have these many features present over here and these many rows. So we have altogether 2000 rows. So we are not going to training it onto the complete thing. We are going to split this into a particular range. So we are going to give 70% of the data to the training set and rest 30% to the test set. Suppose this many and the rest is going to be given to the test set. So for that thing, you would require to split the data into 70s to 30 range. So you can take it to 80-20 also. That is up to you. So for that person, for that thing, sklearn.model selection.train test split is required. So we would be now using this. So please write from sklearn dot model selection import trained test split and remember we are giving the train set as 70% and test one I am giving it as 30% of the data. X train, it's X test, then labels, Y train labels, and then we have Y test then train test split. So here what we have, the transformed value that we would be providing, comma y test size. Here specify the size on which the size, that test size that you want to specify, 20% or 30, whatever, 0.30, and run this. So you can write it from here. I'm waiting for a while so that you can write the things. Why we using test size? Test size, I have told that to specify the percentage that you want to give it to the test data. Like 30% you are going to test, and on 70% training would be performed. For that, this test size is required. Okay. No, test 30% of testing data. It is not training. 70% would go into the train set and 30% would go into the test set. In this way, split would be performed. Okay. Manas, I hope this is clear now. Value error is coming. You would have written something. Some of the variable you would have given it wrongly. That is the thing. You have given some of your variable, passed your variable using some wrong name. That is because value error is coming. Okay. You have many more functionalities inside sklearn library. In every lab we would be telling you which libraries we are using. So like I have shown you here where these are present, like min-max, scalar, train, test, split. So you can use many more functionalities by learning these websites. So yes, there are many more functionalities that you can learn from this scalar. Okay. Okay, Yash. Then we are trying to analyze the prediction of the price range. We are going to train the data, some of the data, and then we are going to predict that what particular feature, what it is going to predict. So how much accuracy we are going to get after learning through the data set. So that is what we are going to classify it based on the price range values. These are the features on the 20 features that on which training is going to be performed, and based on that, it is going to predict the range that that particular data point is having. Okay, so I should go ahead. Okay, should I move ahead? Please reply in the chat box. Uh, the libraries which you would require is like specified based on the analysis or the whatever problem you are solving. Based on that, we ourselves have to learn like which all libraries are to be required. So these are the basic things that we are going to cover in the labs that are mostly required in most of the cases. So these are mostly all these libraries would be required. Along, you would also require few new things also that you can also read from these sklearn.preprocessing. Okay, so most of them are able to do till now. So, and I have answered all of the questions. So let us move ahead with SVM. So what SVM? So we are going to classify the data points based on the SVM classifier. So what support vector machine is? Let me tell you, give you a quick glance of SVM. Support vector machine is actually most popular supervised learning algorithm that is used for classification and also for regression problems. So the goal of mainly the SVM algorithm is to fit a baseline or a decision boundary on the data points that are present into and to classify them into a particular class, so that whenever a new data point is coming, so that it can be put into a correct category. That is what is required. So for that, fitting the best decision line, SVM is required. So here, like you can see in the lecture, also in the previous session, you have seen that how sir has told that how this linear line is fitted across the different types of data points, and how closely they have to be moved ahead. So these boundaries are also known as hyperplane of SVM. So fitting the best line is the main objective of SVM. So it can be linear SVM as well as non-linear SVM if you if the data is linearly separable, then if data set can be classified into two classes using a straight line, then it is linear SVM can be used, and non-linear SVM is used whenever you cannot mark a straight line, then it is a non-linear SVM. So with this short description, you can we can proceed with using the SVM. Here I would like you to tell that here, like we are going to import SVM using sklearn library again. So we have sklearn.svm, sklearn.svm.svc. So we have a regressor also and a classifier also. So here SVC is used, C for classifier, and R is going to be for a regressor. So click on this sklearn.svm. We would be directed inside this, and there we can see many things. Like here, kernel are specified, linear, poly, RBF, whatever we want to take, those things would be given. So here, different type of things are specified. You can read this, and then we are going to move ahead with our discussion. So here, from sklearn.svm import sklearn.svm import SVC. SVC is equal to SVC, and then we have to write the variable, this variable name into which we have called the SVC, that variable name, and then we have to fit. Here we have splitted the data and we have taken it into X train and Y train. So let me first tell you that here, once we have used X train test train split, at that time it is going to split your your values, the training values, into X train and its label into Y train variable, and the X train test, the data points of X test, and then its label is going to be go into Y test thing. So this is the data point, and its corresponding labels are stored. So we have to pass this X train and its corresponding label values to train the data. So you can do this and then see what the accuracy is. What the accuracy that we are going to get. So write print accuracy SVC dot score. It gives SVC dot score. SVC is our variable name that we have used over here, and score is going to give you the mean accuracy value. It automatically computes it from the sklearn library. So this it does using automatic computation. Test Y test. So it is giving 84% of accuracy. Okay, so then we will go ahead and see one more thing. Let us use this time SVC kernel is equal to poly. Different types of kernels are present in SVM. So you can use anything, like this is giving you the suggestion which one to be used here. So you can use anything. If you are not using anything like we have done over here, so it would be by default using RBF kernel. So that is the default value present. So here now we would be using poly and providing the degree. In the previous session, sir has very clearly explained during his linear regression thing for the degree thing that features uses while computing the best fitting line. So here we are using degree 3, and how we are going to fit the classifier SVC dot using fit X train and providing the labels that is present inside Y train. So again, let's print the prediction result, print the accuracy, SVC dot score, and then we can see the X test and Y test values, X underscore test and Y test. This time it is giving you 87.66. So it is like a trial. You have to try different types of parameters, and then you can see which one you are getting the best result. So that this is up to you how you are going to use how you are going to find out the result that where you are giving you are getting more accurate. So again, let us see one more parameter, HLP, and then here we would be using the kernel as linear, and then SVC dot fit X trained and Y trained, and print. So in this particular kernel, linear kernel, while using this, we are getting 95% of accuracy on the test data. So this is what the prediction it is giving. Okay, so this is at degree 2. Okay, someone is getting 85.5. Divyanshu is getting 85.5, 90.5 at degree 2. So you can try it out, different types of values you can try it out, and you would be getting different results. So I'm waiting for a minute so that if someone is behind, they can continue it.
Hello, Shubhangi? You are muted actually.
Yes, ma'am,
Actually, she
I have
is
given
giving
time.
some time. She's giving time from time.
If everyone has done this, I can move ahead. Please write it on chat box. Okay, thank you everyone for your for telling me. Now, uh, one important thing that you must be requiring in your further uh, lab, or whenever you are analyzing the data or you are training something, that is the classification report thing. So from sklearn.metrics, sklearn.metrics report classification report, where you can see the precision record advanced score also. So for that, this classification report is required. So for this, we are going to predict the results and then use that to find out the precision record values. Why pred is the variable where we are going to store the prediction value. Y pred underscore test is equal to SPC dot predict X test, then print this classification report. So print classification report, and then use Y test and the prediction value. So here you can see the precision recall F1 of each of the classes and the accuracy you are getting 95%. So you can like 97% of precision in first of the class, another one is having 93% precision. So this thing you can analyze using classification report. This is also an important library that we have to use it using from sklearn.matrix. We have to import classification report. Okay, so okay, so someone has asked me in chat box, can you please share the collab file on Drive after the session so that we are stuck. Yes, I have already shared the file in lab folder. So you can see that, and it contains the description of dataset as well. So you can view that thing. Then does increasing train test ratio increases accuracy? Yes, of course. If your data set is too large, see, machine learning and deep learning models require a huge amount of data. So if you have a lot of data, then it is all good. But increasing the train test ratio, you can change the ratio, you can't increase it. Okay, you can vary the test ratio, like you can give 10%, 20% to the test set, and remaining would go into the train. Another thing is sometimes we require the validation also. Train, validation, test split, we would be seeing it in our upcoming labs where we are going to split the data into train, validation, and test set. Okay, so can you provide the link to Google Drive again? Yes, from time to time, we are providing the Google Drive link. At the starting of the session, we used to provide you the link. Neha ma'am, please provide them the link, Drive link again. Someone is asking.
It is available on the chat, and I mean, we
Yes.
are constantly giving. This is again given. Just check. So
Yes, ma'am.
I'm again giving it to all. Please note this link somewhere so that you are not supposed to ask it again and again. Please note it down. You may continue.
Yes, ma'am. Can we get the recording of the classes? Whatever material we are having, we are going to provide you. Okay. So
You just don't worry about material. So Shubhangi, you just take care of your lab.
Yes.
So I'm telling participants every time that in the class, please focus on the class, and after the class, you can ask questions. We are already replying to your questions.
If you have any doubt about in this particular lab session, then please ask me in the chat box. So everyone, so please reply me that if you are able to do these things with me. Till classification report, if things are clear to you all, please respond it. Okay then. Thank you very much. So this was all about this data set, this particular data set. For the time being, I would explain you something about the label encoding, why we required it. Yes, after pre-processing, we train and test the data. But pre-processing steps can vary from data set to data set. So that depends how you are going to use the pre-processing things. So next thing that we are going to cover quickly in 10 minutes, a few of the highlights that can help you further uh, are the label encoding. First of all, let me tell you why we have used and we have used the label encoding. This is another data set that is having 14 columns. This is having 14 columns. Just listen to me. I'm only going to tell you briefly about a few of the concepts in 10 minutes so that it can help you further. Here, 14 columns are present and 122 rows are in this particular data set. Do not worry about the data set and this file. I will provide you this as well in your lab folder. Okay, so in this, we are trying to train the data set based on these particular features, and we are going to use classes as the label, as the target label. So here you can see, unlike our previous data set, this is having not fire and fire type of labeling present. For these types of classes, we require label encoding. So this was what I was telling you at that time. So here what we are doing is I have used the same thing to read the CSV file. Then we have displayed it using the data frame. Then we are using df.keys. So here various features are various features are shown over here. You can see that white spaces are present in these column values. So these white spaces are required to be emitted. So for this strip function is used. We will further use this. First of all, what we are doing that we do not require this year thing. We do not require this year column because every row is having 2012 year only. So this is not varying. It is constant here. It is not going to affect anything. So we have dropped this. Someone was asking about why we are using drop. So we are using to drop that particular column and use rest of the column values. So for this df.drop is used. Then we have printed the keys. Okay, so here one column would have been dropped. Now we would be removing the white spaces from the columns. So here we are going to remove using strip function. Okay. So we will be using columns dot strip str dot strip and then see the keys using df.keys. All these column values, we can see that now white spaces have been removed. Now df.month.value counts tell you how many values are present in particular range. Like 7 is having 31 count. You can analyze this thing by going deep into the data set and see these things. So this is not very much important. You can use these things. Then again in the label also there were white spaces present, so that are also required to be that are required to be. So for that again we have used the df.classes.strip. Then here the main thing comes the label encoder thing. Here we have used preprocessing.label encoder and provided classes, that is the target label that we have provided, and then transformed it to the values. We were having which two classes? Not fire and fire classes. So we have given them the encoding thing that we were trying to give it in our previous data. So we have given it as 0 and 1 value. Okay, so then you can visualize it. Okay, so this is another data exploratory thing, not diving deep into these things. For X thing, we have taken here explicitly, we have mentioned the columns. Otherwise, you can use the previous method where we have used the drop method and used the remaining columns. So here we have seen this X is containing these many features. Then Y is having our target classes. Then again, min max scalar as in previous thing. And then we have seen the shape, and then again train test split, and we have used the SVC, the SVM kernel, SVM classifier, and then we have fitted it and tested on the test data set and performed the testing, and we have achieved 89% of accuracy. So this then again we have tried it with the polynomial kernel also, and then again 94.59 accuracy is achieved over here. The main thing in this file was a difference is the how we are handling the data, how we are stripping these things, and how we are using these particular features for our training and testing thing, that is up to us. So this is what one of the exploratory analysis where we are finding out the average of the month. One of the feature is the month, how many like 6th June is having how many values classes. There are approximately uh, 55 there are. So these exploratory thing is up to you, how you are handling these things. This is what another file. I just quickly want to describe you few of the concepts. That was all from my side for today's lab. If you have any doubt, you can ask me. Okay, this was all from my side for today's lab. Any doubts? Yes, I have told you I'll share. I'm going to share this data set as well as my Python file. Don't worry about this. So I hope there is no doubt right now. Label encoder is used to assign a number. Yes, numerical to convert it to a numerical form for your label. Okay, for that it is used. Ma'am, I'm done from my side. There are no more questions left to be answered. You can find the accuracy of train set, but we used to report the testing set accuracy in most of the cases. So, so we don't report the train set accuracy, so that is why we have not computed it. Although you can yourself see that.
So this
Yes,
is a good picture that Shankara Arts and Science College students are sitting together and doing. That's wonderful.
Anna University also, they are doing together. Yeah.
Okay, that's very nice. So we request you, please send your pictures as well, right? We will use it in our activity booklet. We request the coordinators to send the pictures of their colleges if the girls or the students are doing together. Right? Thank you.
So please switch on your video so that we can take a picture. And then I will come to your questions.